Good morning, everyone. Welcome to Do Drones Make Sense for My Business? And thank you for joining us this morning. My name is Marnie Nesher, President of the Business Journal News Network. This webinar is being presented by the Business Journal News Network and MICRODRONES. Some quick housekeeping before we begin. If you have questions during the presentation, please type them into the chat function at any time, and our presenters will answer them at the end of their presentation. Please let me introduce Mike Dziak. He's the Marketing Director for MICRODRONES, and he will introduce our presenters today.
Thank you very much, Marnie, and good morning, everyone. Thanks for dialing in. We really appreciate you spending some time to learn about whether or not drones may make sense for your business. We are a company that sells fully integrated drone solutions with sensors, cameras, and the proper geospatial boards so that you can achieve results in the field much easier than by traditional methods. So we get a lot of great questions from social media. We get questions that our salespeople field out on sales calls, and we wanted to compile those frequently asked questions into one presentation and to give you an overview today. First and foremost, I'd like to introduce Dr. Mohammed Mustafa. He recently joined our company. He is the director of our MD Solutions team. That is our product development team. Dr. Mustafa has a PhD in geomatics engineering from the University of Calgary with more than 18 years of experience. He's managed projects worldwide and contributed to more than 160 technical publications. So we're very happy, obviously, to have him on the webinar today, as well as to be a part of our company. To kick things off, before we get into the 20 questions, I would like Dr. Mustafa to do a quick overview of how this technology came about and where we are today. So without further ado, I'd like to turn it over to Dr. Mustafa.
Thanks, Mike. Welcome everyone to our webinar. Our concept here is to focus on the integration rather than invention. We integrate well-proven technologies in the form of sensors such as cameras, laser scanners, GPS, and inertial measuring systems. The way we do geospatial in general, conceptually, is we acquire the data of a natural scene in 3D as an XYZ at a certain moment of time using a sensor on board the platform. And the data turns into a group of pixels we call an image. Once we do the necessary data processing and adjustment in the form of 3D modeling, we bring back the 3D natural scene at that moment of time into our computers. A quick introduction on the sensors. We categorize sensors as active or passive. The active sensors produce or launch a pulse, and that pulse returns back to the sensor, collecting some information such as laser scanners or radars, or passive sensors such as cameras, where we release a shutter and collect an image directly. GPS has been used since the 70s when it was invented in many applications. It started in the military domain, and it actually ended up in the civilian domain in the late 80s. You now have it in your watch, in your cell phone, in your car for car navigation purposes, for recreation purposes, hiking and biking, as well as what we do with it is in the precision mapping field. We integrated inertial measuring units together with GPS in order to determine the position, velocity, and 3 angles, roll, pitch, and heading of any platform, either driving or flying. In our case, the drone is flying at 200 times per second. A quick overview of the currently available sensors. The large format cameras are those used extensively in the last couple of decades on board manned systems. And those cameras, their price range from $1 to $2 million. Medium format cameras were initially designed and produced for studio photography. They have been used on board, again, manned systems. Spherical cameras are invented for panoramic imaging. And the most important category of cameras for us is the small format cameras because of their low weight and power consumption. Other sensors being used around the world on board drones include LiDAR, light detection and ranging, hyperspectral scanners, synthetic aperture radars, as well as multispectral scanners. Applications, believe it or not, one of the applications that is used most in the geospatial industry is the automotive. What it does is the folks up in Toyota and Ford, at Audi, BMW, and so on, they use multiple sensors and a great assembly, cameras, lasers, and radars, and integrate that to help with their design of the vehicles, as well as the aerodynamic studies, as well as the crash testing, and so on. Aerospace engineering, the picture on the right-hand side shows the polka dot test that was done recently by NASA, US Navy, FAA, and DLR, which is the German space agency. That collaboration was done to do a crash test of a vehicle, as you can see in the picture here, and the dots all over the vehicle body are basically measured down to a sub-millimeter accuracy. On the left-hand side, what we're looking at is the typical way we design our spaceships, again, using the geospatial methodology. In the medical engineering application domain, we have here on the left-hand side the MRI, which is a typical medical engineering of geospatial science, where we have a group of sensors in the body of the MRI device to produce the 3D model of a human organ, as you can see on the right-hand side, of different levels and different depth. In the geospatial field, we use the geospatial science in the form of airborne mapping, either manned or unmanned, which is the topic of our webinar today, or in the mobile mapping on the ground. What we end up with, as far as products are concerned, is something called orthophotography. The picture on the left shows a typical airborne image where you can see the sides of buildings, and the orthophoto version of it, after you do a certain workflow of processing, you end up with practically a map, a high precision map that doesn't show the sides of buildings. This is a topographic 3D model, triangulated irregular network showing the break lines, and a standard 2D planimetric map. This is a LiDAR product called 3D point cloud, showing the high tension transmission lines and their towers. And the last picture shows a 3D photorealistic city model. As far as the data is concerned, we have digital frame imagery, video imagery, and LiDAR, or laser scanning imagery. And if you can tell from the picture on the left-hand side here that the precision of what you're looking at, because of the density of the 3D point cloud, is so high, you could imagine that it's an image, although it's not. I will turn the floor back to you, Mike.
Thank you very much, Dr. Mostafa. Next up is Chuck Dorgan, our sales director for the United States. So now you have a sense of how this technology evolved, where it came from, and where we are today in terms of using it for surveying and mapping. And Chuck Dorgan, as our sales director for the U.S., has traveled the far corners of the country for the last year and a half, discussing these topics with customers and companies that have an interest in employing this technology. So we're going to start the Q&A section of our presentation. And question number one, Chuck, is why use drones for surveying and mapping? Why would I want to consider this?
Great question, Mike. And I hear this very often. And it's quite simple. It saves time. It gets more done. It improves worker safety and takes away from parts of the job that are dangerous, dull, or dirty. More competitive. People are asking for drones and for surveying. I've got customers that literally come to me and said, you know, I need to be using drones because I got some of my biggest customers are asking for it. Collect data without shutting down regular groundwork. I'll get more into that because that touches base on safety as well. And for all the surveyors on the call, with our DG solution, which stands for direct georeferencing, you can slash post-processing times and eliminate the need for GCPs. And actually, Mohammed will talk a little bit more about that after my presentation.
What about the Juniper Flats Basin Survey project that you recently worked on, Chuck?
Oh yeah, this is a great project out in Riverside County in California. I'll start with the Riverside County mission statement for this project was to protect people, property, and watersheds from damage, destruction from flood and stormwaters, and to conserve, reclaim, and save such waters for beneficial use. And the key question from them was the reservoir built to specifications? This project was nice because already some of the survey work had been done, so they could compare what we did side by side to what was already done. So why use the MAPR DG? Well, first of all, you're getting survey grade results. It's very accurate. It's fast to collect and process the data. One of the contributors to that is not having to install ground control points. And some of the important benefits are it condenses the project schedule from weeks or months into one day. And this is a live data, an actual project that we did side by side. So here's some of the flight profiles and parameters here. We surveyed and mapped an area of 37 acres, flying height of 120 meters, which is 400 feet, which is the maximum height you can fly small UAS in United States. The flight speed was 6 meters per second. We took 72 images. GSD was 1.7 or 1.8 centimeters, and the flight time was only 8 minutes. So literally less than 2 hours later, after collecting all the data from the job site, we have a digital surface model. For those that aren't in the surveying business, it might not look very attractive, but it's from the supervising land surveyor, Joshua Tremba, was ecstatic with these results, and was shocked by how quickly we could do this. So, you know, this is a key point here. Collecting imagery and showing some pretty pictures are really not much unless you have accuracy. You know, you got to be able to meet the customer's requirements. So for this project here, we had 11 points on the project. 0.6 was the ground control point that we used in processing the data. The other 10 points were just used as checkpoints to check our accuracy. And the accuracy actually fell right within our as advertised accuracy of 1 centimeter in X, 2 centimeters in Y, and 5 centimeters in Z. So very good results.
All right, Chuck, thank you. What about getting started with using drones? It sounds complicated. Is it? Is it hard?
No, it's very easy. I have to give props to the FAA for doing a good job of turning the ship around, because it was not easy back in the day. But in August of 2016, they introduced Part 107 that, you know, it is really easy now. Just about anyone can go out there. Basically, you want to find a UAS that's a good match for your application. You know, and a hint would be a salesperson should start talking or should be asking you questions about your business and not so much about the specifications of the drone. It's important to meet the needs of your customers. Getting your Part 107 remote operator's license, which I will talk about in a little bit more depth later. Learn to use your drone system, and that's one of the things we focus on. It's one of our core competencies is our MD Academy. We're great at training our customers. We will, you know, after at MD Academy, you're fully qualified to fly missions, plan missions, fly them, and collect the data. Most flights are automated, so it's very easy to get started. And the MICRODRONES technical support has a turnaround time within 1 business day when you have questions or issues along the way.
What about regulations, Chuck?
Well, I gotta say they're pretty straightforward and they're pretty easy to understand. And you know, it's not a long list of regulations you need to know about. There's a few and they're easy to know. The first one is you have to pass the initial aeronautical knowledge test at one of the 690 FAA test centers around the country. On their website, you can pull up a PDF and it has it listed by state. And I'll be more than happy to share that with anyone who has troubles finding it. You have to be vetted by the Transportation Security Administration. Obtaining a remote pilot certificate with a small UAS rating, like existing pilot airman certificates, it never expires. And you have to have a recurrent aeronautical knowledge test every 24 months. It's more of a little refresher. You have to remember to report any accidents to the FAA within 10 days of any operation that results in an injury or property damage of over $500. And conduct a pre-flight inspection to include specific aircraft and control station systems checks to ensure small UAS is safe for operations. One of the things, MICRODRONES provides this checklist with all of our systems, so we make it easy for you. And in some of the other basics, and in all of these, there's, or most of these, I should say, you can apply for a waiver, and if you have justification and mitigating controls, you usually can get these waived if you have, like I said, you have mitigating controls. But you must fly during daylight. You can't be flying after dusk. You have to fly with under 400 feet. This is the ceiling for class a small UAS. You have to establish direct line of sight. No flying beyond line of sight. No flying in national parks. No flying directly over people. A lot of it's straightforward, common sense.
Now we provide these Cliff Notes overview of what the regulations are, but obviously the Federal Aviation Administration website is your best resource. So we provide the link here. Anybody who needs that after the call, certainly send us a message and we'll get it to you. And when you go to their search bar, you can enter the keywords that we have here and you'll be able to find everything you need related to becoming a pilot. Chuck, what about when someone decides to work with you or to work with MICRODRONES, will they have help along the way or do they have to kind of just figure it out on their own?
Oh, they'll have all the help they ever wanted. That's probably one of the things, one of the feedback that I get back from our customers all the time is how helpful we are. Our MD Academy training, we teach you how to learn how to use your UAS to the fullest. We offer basic training as well as more in-depth payload training. Technical support, it's easy to get in touch with us, either email or phone call. You usually get an answer within a business day, and those folks that you're talking to are folks that work on the drone and have a history. There isn't a tier 1 call center somewhere else where they don't understand the product itself. The marketing and PR support. MICRODRONES has a world-class marketing department there to help you with your business, and customers love it. We're there to support.
What other things should people consider when they're choosing a drone solution? There's a lot of products out there in the market. What are the main things to think about, Chuck?
Yep, good question. Cost over time and ROI are obviously key factors. Data accuracy. So not all results are created equal. Make sure you choose a professional system. There's a lot of systems out there that folks would look at because of the price tag on there, but something at the end of the day, if your data is not accurate, then you've wasted your time. The flight times with specific payloads are probably one of the very first reasons why folks will actually turn to MICRODRONES. We have industry-leading flight times. Resistance to environmental changes, obviously temperature, heat, cold, wind, rain, all that kind of stuff is important factors there. You don't want your drone, your investment to be destroyed by adverse weather. Technical support, quality engineering, ability to swap out payloads is another key thing. I call our MD4 1000 kind of like the Swiss Army knife. You can do lots of different things with it. And company stability. How long has that company been in business? There's a lot of overnight businesses out there. It's the Wild West. So be careful and do your research.
Thank you, Chuck. What about the difference between buying a drone to do work and buying a complete UAV solution? What does that term really mean?
That is a really good question. I'll tell you what. There's a lot of confusion out there with that because there is a specific difference between them. A drone is an aircraft. If you have an aircraft and you want to do something with it, the user must figure out what sensors to use, how to integrate it, how to mount it, how to software. There's a lot of science behind it, and MICRODRONES has taken all that out. We've done it and figured it out for you. A UAS, unmanned aerial solution, is different than a drone. It's a complete UAV solution like MD Mapper that includes everything you need to perform specific applications. So we've done all the hard work for you. It's taken us years to master it, but we've done it, and we've done it with the latest and greatest technology.
So in terms of microdrones, Chuck, what complete surveying solutions do you offer today?
Yeah, we have three packages here. Starting from left to right, we have the MD Mapper 200. That is using the MD4 200 airframe, which carries just over a little over a pound, has a flight time of 15 to 20 minutes, and covers about 70, 80 acres of mapping acreage and a single battery charge. The MD Mapper 1000 is the MD4 1000 airframe with an Alpha 6300 camera underneath it. It's a 24 megapixel camera, so it's professional grade. You get fantastic results with it, but you do need to install ground control points to use it. And to the far right, I would say that probably our best seller in 2017 so far is our MD Mapper 1000 DG, which stands for direct georeferencing. That's again using the MD4 1000 airframe, but it has a Sony RX1 R2 camera, which is a 42 megapixel camera, and it uses the Aplonix APX15 board, which has its own dual GNSS receiver and IMU, and does not require ground control points. So we have a little bit of a, oh, go ahead, there's a question here on how MicroDrones Mapper solutions save time in the field. So we have a little bit of a side-by-side comparison between the Mapper 1000 and the DG. Looking at the time savings, the very first time savings is not having to install ground control points, and it's roughly 2 hours, give or take, whether it's 1 hour, 3 hours, or 4 hours. It's a big chunk of time that you have. So you'll get about a 2 hour savings in this scenario here. The flight time, 35 minutes for the Mapper 1000, where you actually can reduce that with the Mapper 1000 DG, saving you 20 minutes, and the data processing is 12 hours for the Mapper 1000, where the Mapper 1000 DG is only 4, saving you 8 hours. So if you total this whole thing up, you're looking at 15 and a half hours for the Mapper 1000, 5 hours for the DG, saving you 10 hours and 20 minutes by using the DG system.
And I think, Chuck, in terms of the data processing, typically it's about 40% of the time is work and prep in that, and the remainder is processing time or rendering time, correct?
That is a great point. So what Mike has brought up is it's not push button. 40% of that time you're seeing there, you have someone at the computer that understands the data, that's doing some work, identifying the ground control points on the ground and so forth. And so it's not a push button and walk away and let the computer just grind away at it. So about 40% of those times are manual.
But the remainder is the computer doing the work too. So that's a good thing. How long do MicroDrones UAVs fly on a single battery charge?
Industry leading. That's, like I mentioned before, it's one of the main reasons we get contacted is because of those industry leading flight times of 30 to 45 minutes with a payload with one battery charge. Obviously, there's the 30 to 45 minutes is a big variance, but the weather has a lot to do with it. Wind, your payload, your altitude, and your temperature all play a factor in there. One of the things that I'm very excited about is we just recently released Resume Flight. Now what this does, in the past, if you had a 2 or 3 hour mission, you had to, as you're using the MD Cockpit software, it's going to tell you approximately how long that flight's going to be as you're creating it. And so if you're doing a mission and you have a 2 hour mission, you're like, well, I can't do this with one battery. So you'd split it up into 2 or 3 missions. Now with Resume Flight, you can continue to move forward with that 2 hour mission, launch the drone into the air, put it in waypoint mode, let it do its thing, and when it's time to bring it back to change the battery out, you take it out of waypoint mode, bring it back, land it, change the battery, launch it again, and put it back into waypoint mode, and it will start where it left off. This is key for post-processing. Now your analyst back in the office doesn't have to try to marry up 2 or 3 data sets. They have one complete data set.
What about if the weather's bad?
And for those in New York, this thing would be sitting at the desk like 300 days out of the year if it wasn't for being as robust as it is, it can handle winds of up to 20 miles per hour, up to 25 mile per hour gusts. Be careful at the anything above that. So I don't recommend flying over 20 miles per hour wind, but that is pretty strong wind. We've done some mapping missions in the wind that strong, and it's amazing, to be honest with you. Rain up to 45-degree angle rains, torrential downpours will not bring this thing down. Although photogrammetry results are not ideal in the rain, but at least your investment's not going to get destroyed if a rainstorm comes in. Snow, no problem. Dust, heat, and cold, we can operate up to 112 degrees Fahrenheit and as low as 14 degrees Fahrenheit. So we fly all winter long, and it's resistant to electromagnetic fields around power lines and things like that.
What about on the job safety? Are there ways to improve that for your employees by using UAVs?
Yep, and this is actually a good selling point for folks that are interested in getting into UAVs but are getting resistance within their company. Safety is always important with all companies, obviously, and this is an angle that everyone should think about because it's real. You don't have to put humans on high structures like wind turbines and things like that, or dilapidated dams where concrete's falling apart. So it's obviously safer that way. Great for dangerous industries like mining and construction. In the past, you'd have to shut down part of a mine to measure piles of whatever your inventory may be. You don't have to do that, and you also don't have to put any boots on the ground, as they call it. Same with construction. Anytime you can keep a person on a construction site that doesn't necessarily need to be there, that's obviously safer. And like I said before, access to crumbling structures.
What about flight planning, monitoring, extracting the data afterwards?
Well, it's funny. I say this all the time. It's so easy that even a sales guy can do it. And I have my own tablet with MD Cockpit loaded on it to prove it. So planning the flight is simple, obviously, using MD Cockpit. You just call up the location with MD Cockpit, which utilizes Google Earth. Use your fingertip to draw a polygon around the area that you want to be mapped. You have to select your camera/sensor because there will be certain things that the software will be looking for certain sensors. The process takes literally less than 5 minutes the first time. And if you have a regular mission that you want to fly, I have a lot of open mind customers that fly open minds. They want to fly the exact same mission. You can save it and use it in the future. You just pull it up. You also use MD Cockpit tablet to monitor the mission real-time telemetry data. And extracting the data, it can be accomplished in minutes using via Bluetooth.
What about special insurance? Do I have to invest in insurance to use a UAV for my business, Chuck?
No. Interestingly enough, the FAA is currently not requiring companies to have liability insurance. Not sure how long that's going to last. A smart business person would probably recommend at least having liability insurance. But not to worry, because actually, surprisingly, the insurance and the premiums are rapidly dropping and are pretty affordable right now.
What about adoption that you're seeing out in the field, Chuck? What kind of energy and urgency are you seeing for surveying and mapping companies to adopt this new technology?
Text message or an email on a daily basis of an article that talks about this from friends and family around. I'd have to say that the commercial market is about to explode. Just a year and a half ago, people didn't even know there was a commercial market. In the United States, the FAA has approved more than 300 commercial drone licenses since Part 107 was passed, which was August of 2016. That would be less than a year ago. About 24,000 businesses have taken to the skies. Throughout the world, the global market for commercial application of drone technology is currently estimated at $2 billion, and that is expected to grow to $127 billion by 2020. Absolutely amazing.
Well, thank you very much, Chuck. That was very helpful. I hope that those in the audience had some of those same questions. Next, we are going to talk a little bit more about the direct georeferencing technology that Chuck referred to earlier in the webinar. So we kind of start here with what has 4 rotors and eliminates the need for ground control points. This guy. It's our MD Mapper 1000 DG, our flagship product. And here to talk about that for questions 16 through 19, we're bringing Dr. Mostafa back. We consider direct georeferencing to be a game-changing technology in this industry. So in this next section, Dr. Mostafa is going to address the following questions. What about corridor mapping long linear structures like roads, canals, power lines, railways, oil pipelines? What kind of accuracy can you achieve with an MD Mapper 1000 DG? What is direct georeferencing exactly, and how is it superior to some previous technologies? And can I really stop using ground control points with an MD Mapper 1000 DG? So I'm now going to turn control back over to Dr. Mostafa, and let's change this slide. Oh, here we go.
Well, I will start addressing those questions, Mike, by introducing the concept of georeferencing in the geospatial field or in photogrammetry. Georeferencing means you're referencing some piece of information to the ground or to the geo, which is the globe. And for example, your zip code is a georeferencing piece of information because it puts your house on the map for the postal service. All you need to know is the zip code, and you don't care much about the address. So in mapping industry, georeferencing is where we try to reference an image or a laser pulse or a radar pulse or any piece of information that is measured up in the air on board the drone, to reference that to a mapping frame of reference on the ground to produce our mapping products. Two technologies are available. The old technology is called area triangulation. Lately, it's been called shape from motion, which is pretty much the same thing. Practically, this technology is all about the ground control points. And ground control points are points you establish on the ground and you survey them in using GPS. And it's a long process, a tedious and laborious process, and requires access to the mapping area or the area of interest at all times to establish those ground control points. So that's a prohibitive feature right there. Ground control points are needed at all times. Then we do some measurements and computations, and that's the name of the game here with this technology, is that you compute where your camera was at the moment of camera or image acquisition, and then the angles of the camera with respect to that mapping frame of reference. And then you produce the mapping products. What we have done is that we integrated a technology called direct georeferencing, which is centered around measuring everything up in the air. So we measure we basically acquire the image or the laser scan or the laser pulse or the radar pulse or any form of image measurement together with GNSS and inertial data. And that allows us to be flying free like a bird. We don't need any information on the ground, such as ground control points. After that, we run some quality control procedure and then produce the mapping products with no need for ground control points, unless you would like to assess your geometric accuracy by using some checkpoints. Now, the way it actually works is that what you're looking at is the full description of the mathematical model. I'm not going to go through this. I just want to mention that all of these parameters, such as the measure or the measurable quantities, such as the caveats, such as spatial offsets between the antenna of the GPS on board the drone, as well as the inertial measuring unit, and the rotations between different coordinate systems, represented here in the form of matrices. All of that mathematical description of the process has been very well taken care of, and it's sitting in a software that is really user-friendly software. So from the user perspective, they have the best science available currently, but is already programmed in the form of easy-to-use software. On top of that, there is an error budget, and error budget means that we take a look at every single source of error coming from GPS or inertial or from imaging or from laser, and we basically did our homework analyzing all of these errors, and we produced our error budget models. So we've done our homework here, and that's something that, again, the user doesn't have to go through or pay any attention to, because we have that in the form of a workflow procedure for the user to use in a very easy way. Now, what direct georeferencing does for us is actually it allows our drone to fly really free, and we have no any necessity of having access to the site on the ground to establish ground control points. For example, we can actually capture one image and add a digital vision model to produce an ortho from one image. We could do the same for a stereo pair or a strip or a flight line of images. And that's a key differentiator between the direct georeferencing technology and traditional area triangulation or shape from motion, because we can handle the corridor mapping domain. And corridor mapping constitutes around 60 to 70% of all the mapping products or mapping projects around the globe. Transportation networks, inspection, railroad tracks, and high transmission power line, and so on and so forth. A real-world example on top of the one that Chuck illustrated from Juniper Flats in California. We have here another example from the Frere Dam in Quebec in Canada. The dam that we're looking at here, actually, we were not allowed to have any access to the dam, and the only way to survey and map the dam was to fly above it without having access to actually do anything on the dam. So we established a couple of checkpoints on this end of the dam and 3 checkpoints at that end of the dam, and we flew 2 flight lines, 12 minutes of flying time, 14 kilometers an hour platform speed, and we have those checkpoints around each end of the dam. The final product is a true ortho, and the true ortho has the following accuracy of 3 centimeters in easting and 1.5 centimeters in northing, and that basically summarizes the quality of the capability of flying a drone equipped with the DG system, and the entire solution could map a large structure like what we're looking at, and 12 minutes worth of flying time and a couple of hours of data processing to produce a final mapping product of this quality. And that concludes my presentation to address your questions, Mike.
Thank you very much, Dr. Mostafa. So now at this, we have some time remaining to field some questions from the audience. There must be some additional good ones out there. So we will open it up. You can type your questions into the message chat, and then we'll read them to the group, and either Chuck or Dr. Mostafa will answer your questions. So go ahead.
So we actually have already received a couple of questions. Let's see. Mike, you might want to read this. It seems a little technical for me.
Okay.
Here you go.
Okay, so the first question. So I want to ask if the flight of the DG-1000 is programmed with coordinates and the accuracy on the field versus GNSS on the field.
Programming the mission is so simple on the template. On the tablet. The tablet has a mission planning software that is so easy to use, and truly the location of the images is desired to cover the area, and the precision of the location of the images is not necessarily required to be high precision. All we need to do is acquire images to cover the area and to have the level of overlap needed for the kind of application we are trying to accomplish. So in some applications, they need 80% overlap and 40% side lap, or 60 by 40, or 60 by 20, or 30, and so on and so forth. That depends on what kind of mapping application we are trying to address and what kind of mapping product we are trying to develop. And the precision of the image up in the air where it is during the data acquisition is actually measured by the DG system. So we measure those down to the centimeter accuracy using our DG system comprising a GNSS inertial system.
Thank you, Dr. Mostafa. Next question. What is the effect? Oh, hang on one second. We had a couple more questions come in. Okay, next question. What is the effect on sparse point cloud density of having far fewer images with the DG solution? I'll read it again. What is the effect on sparse point cloud density of having far fewer images with the DG solution?
Mohammed, would you like to take that question?
Sure. When you have a lot less images because of the capability of the DG system to process a minimum number of images with no ground control points to produce a reliable mapping product, at that time you have all sorts of data and measurements to produce the highest possible mapping, like highest quality possible mapping product. So the density of the point cloud is really something that could be produced using your software or in your software environment. You could adjust it to or configure it to collect whatever density you require for your mapping application. So the fewer images are not necessarily gonna reduce the density of your final 3D point cloud. What matters at the end of the day is that you have the right quality in that 3D point cloud, and the density will be produced anyway, no matter what the overlap is like. There is a misconception out there that when you have more images, you have better data. That's absolutely wrong. The more data you have, that means you have with each single piece of data some error associated with it. So, and this is something that they teach in academia to geospatial students in year one, is that when you have more measurements, you have more errors associated with the measurements. So in the direct georeferencing domain, we don't have the large data. We actually have the good data. We focus on acquiring good data, not really abundance of data, because the more redundancy in the data, the more errors you can have. And that's not what we do. We focus on acquiring the good quality data at a minimum, and because we have the measuring tools, the DG system on board, we don't necessarily need very high overlap in the images to produce high density elevation models or 3D point cloud.
Thank you, Dr. Mostafa. Next question, this is a good one. Can you plan missions using GIS software, or do all missions need to be set up in MICRODRONE's own software package?
I can take that question. You have to use the MD cockpit software to plan the missions, but it's very simple to do. If you have something in GIS, you can fairly easily replicate that with the MD cockpit software.
And what about file types? The next question related to this is, what file types are extracted from the sensors? TIFFs, LAS point clouds, is all of the output compatible with GIS applications?
I can take that. Actually, the final mapping product is 100% compatible with in the GIS domain as well as in the CAD domain.
What is the cost for the MD Mapper 1000 DG? And are there additional costs, software, sensors, etc.?
And that's a good question. You're in for this complete package, you're in the $60,000 range, $64,000 range. The only additional cost is training with that, and you're looking at about $5,000 for hands-on. It's a week-long training class with one of our folks from MD Academy. But that gives you everything you need to fly: case, software, all the sensors.
I have another question. It says, can the MD Mapper 1000 DG carry a, I'm sorry, I'm not sure I'm going to say this right, a BASIN topo LiDAR sensor, or are the sensors still too big?
That's Dr. Mostafa can answer that question.
Sure. Actually, we have a LiDAR product at the moment deliver to 2 clients that have been using it for the last few weeks, and that product will be available for sales very soon. And it actually showed a great success. The development has been taking place in the last 6 months, and the results that we're having now are excellent results, and they're actually competing with the accuracies and quality and density of the manned large LiDAR systems.
Sorry, everyone, we're still fighting with technical difficulties here.
Not a problem. Hey, I want to just say, with relation to the last question about pricing, we absolutely love to do demonstrations and to kind of show off our products. So anyone interested in further discussions on pricing and demonstrations, please contact me. Mike has a slide with my contact information on there, but we'd be more than happy to come out and show you the DG system in real life.
There is a couple more questions. Do you have time for that?
Oh yeah, I do.
Okay. So the next question is, can you please describe the upcoming SICK LiDAR solution relative to your competitors, like Phoenix?
Well, actually, I can take that question. There is a little bit of a, again, the mapping science and the mapping field in the drone domain is still evolving. It's been evolving for the last 3 years. However, the lessons learned from the manned industry, which happened to be around since the 70s, the LiDAR products started back to be like full operational products back in 2001, 2002 time frame. Before that, there was the laser range profilers where we had only one pulse without a scanning mirror. So anybody that works in the mapping industry and used LiDAR in the last like 20 years has learned many lessons. So one of the important lessons is that the laser sensor is actually an important part of the reason to produce a quality mapping product. And the mapping products we end up with the LiDAR could be digital surface model, digital terrain model, or digital vision model, triangulated irregular network, or use all of the above together with some images to produce 3D products or true orthos or 3D city models and so on and so forth. So the differences between the sensors, like the SICK sensors or other sensors or Regal sensors or Phoenix sensors will contribute to the end mapping product. So what we offer currently, we have 2 sensors, and on top of that, we're even willing to integrate custom sensors if need be.
Last question I see here is if you could please repeat the cost and duration of the training.
Okay, so the basic mapping, flight training and basic mapping is $3,000. It's 3 days. We usually block out 5 for bad weather. If you're going to buy a DG system, it's an extra $2,000, and it's an extra 2 days just dedicated to that. So you're looking at a full week of one of our professors from MD Academy to come to your site and teach you how to use it.
Any other questions from the audience? We have about 5 minutes left. If not, in closing, we again want to thank you all for joining in. Sorry that we had some technical difficulties, but I hope that you were still able to absorb some good answers to your questions and to get a better sense of whether drones may be helpful for your business. We remain available for questions, not just on this webinar, but going forward. Chuck Dorgan is your point of contact. It's chuck.dorgan, CHUCK.DORGAN at microdrones.com. That's microdrones plural, MICRODRONES.com. We would love to have more of your questions. If anything wasn't answered or if you want more detail on that, that's what we're here for, and we would be really happy to talk with you and to help you make sense out of whether this is something you're interested in moving forward with. Again, thank you all for your time. Do we have any more questions come in there?
I don't see anything else. Thank you again for joining us. We hope the content was informative, and we hope that you enjoy the rest of your day.
Thank you.